When beginning to design an airside system, one of the first steps is to place air terminals. Grills, registers, and diffusers all fall under the air terminal category. Let's begin by placing supply air diffusers in the ceiling. I'll open the Level 2 HVAC RCP view by double-clicking the view in the project browser. I'll zoom into the southeast portion of the building. To place an air terminal, on the Systems ribbon, in the HVAC panel, click Air Terminal. Once I do, the ribbon changes to the Modify Place Air Terminal contextual ribbon. Also, the Properties palette changes, and the type selector contains a list of air terminal types already loaded in the current project. You can select the type of air terminal by choosing from this list. If the type you want to use does not appear in this list, you can load it from the Revit component library. To find more air terminals, in the Mode panel, you would click the Load Family tool. Moving into the drawing area, I can simply click to place an air terminal. However, when I do, a warning appears stating that none of the created elements are visible in the reflected ceiling plan view. This is because we are looking up from the cut plane in this reflected ceiling plan view, and the air terminal was placed below the cut plane. I'll click Modify to end the command, and then switch back to the Level 2 HVAC plan. You can simply click in blank space to dismiss the warning. Now, when I zoom into the space where I placed the air terminal, it is visible. I'll select the air terminal. Realize that this supply air terminal family is a non-hosted family. Therefore, I was able to place it without a host, such as a ceiling. Looking in the Properties palette, I can see a level, host, and offset parameter. Even though the host is Level 2, this element did not have to be placed in a host element, such as a ceiling. You can create air terminal families as hosted or non-hosted families. Non-hosted families allow for more freedom during placement. You just have to make sure that you set the offset to match the ceiling height. So I'll change this offset in the Properties palette to match the ceiling height at 8 feet or 2,438 millimeters in the metric file. Now when I switch back to the reflected ceiling plan view, the air terminal is visible here. The quickest way to lay out air terminals is to place one that is aligned to the ceiling grid and then copy the air terminal. So I'll select the air terminal and then click Move in the Modify panel of the contextual ribbon. To move the air terminal, I'll select a corner as the Move Start point and then click at an intersection in the ceiling grid. Next, I'll click Copy in the Modify panel of the contextual ribbon. Select a corner as the start point, and then move the cursor down and select another ceiling grid intersection. At this point, I can press Ctrl and select the other air terminal to add it to the selection set. Now when I click Copy in the contextual ribbon, I can select the Multiple option in the Options bar and copy both air terminals into the adjacent rooms. I can continue placing copies by selecting intersections in the ceiling grid. As you can see, this method is much quicker than placing air terminals individually. I'll click Modify to end the command. After air terminals have been placed, you can modify the airflow. But first, we can check the space to see how much airflow is needed. For example, I'll select the space Instruction 202. In the Properties palette, when I scroll down to the Mechanical Flow section, I can see that this space requires 556 CFM, or 262.4 liters per second in the metric file. However, I currently have almost twice as much airflow as needed, as can be seen in the actual supply airflow field. The calculated supply airflow parameter for each space can be populated by the Integrated Heating and Cooling Loads Analysis tool, or from an external GBXML file. If you use another program to calculate the loads and do not import a GBXML file into Revit, you can enter the required airflow for each space into the specified supply airflow field. The actual supply airflow is based on the supply air terminals placed in the space. If you have air terminals placed in the space, but the actual airflow parameter is not populating, whether it be supply, return, or exhaust airflow, then you should modify the room calculation point on the air terminal. Sometimes an air terminal may be placed slightly above the space without you realizing it. This can produce errors whenever you create schedules or legends to look at the actual airflow versus the required airflow. To enable and modify the room calculation point, you must first open the air terminal family in the Family Editor. To do so, select an air terminal and then click Edit Family in the contextual ribbon. Revit opens the family in the Family Editor. In the Properties palette, scroll down to the bottom where there is a room calculation point parameter. To enable this parameter, simply select the checkbox next to it. With the parameter enabled, a point appears in the drawing area with a dashed line connecting it to the origin of the family. As you can see, at the moment, the point is above the air terminal. So when I click Load into Project in the contextual ribbon, and overwrite the existing version in the Family Already Exists dialog, the actual supply airflow parameter for the spaces will be incorrect. You can see this in the Properties palette when I select Instruction 202 again. So be aware of the room calculation point if the actual airflow parameters are off. I'll use the Switch Windows tool in the Quick Access toolbar to switch back to the family. In the Family Editor, I'll select the room calculation point. When I do, a 3D control appears at the point. There are 3 arrows on the control, each pointing in one of the 3 coordinate directions. You can use these arrows to move the room calculation point. I'll click and drag the blue arrow down to move the point below the air terminal. Next, I will click Load into Project again. In the Family Already Exists dialog, I'll click Overwrite the existing version. Now with the room calculation point inside the spaces, the actual airflow parameters are once again correct. I'll select the 2 air terminals in space Instruction 202. Looking in the options bar, I can see a flow parameter. Here, I'll enter 280 CFM or 132 liters per second in the metric file. Now the actual supply airflow will be closer to the required airflow needed in the space. As you can see, placing air terminals is a simple process. The main thing is to make sure that they are placed at the correct elevation.